Good morning students. We will continue the previous class. See here, now we have to discuss about the reflection of light. So this is one of the property of light. In this chapter already I said we are going to study about the properties of light. Many are there. Reflection there, refraction there, dispersion there, many are there. Just briefly here we should know about what do you mean by reflection of light. See here, just look on this diagram. Here I have mentioned XY. This XY is interface. It is one surface which is going to separate two medium. XY is one surface which is going to separate two medium. Means what? Above this XY there is one medium, and below that XY, I mean it is a medium, one medium. It may of glass coated at the bottom, glass sheet coated at its bottom. See here two mediums are there. Above this XY interface, air medium is there. Below means that is glass material. Lower side is coated. Interface means what? It is a surface which is going to separate two medium. So now see here, this shading indicating the lower part of that glass sheet is painted. So now here I have mentioned incident light ray, reflected light ray and Dharwad. Just look on this one, on this diagram. Here this light ray is coming and it is going to hit that interface. It is going to strike on that surface. When that light got incident on this surface, that surface is going to bounce back that light into the same medium. Means what? From which medium that light ray came to that medium, this interface sending that light. That light came along this path, it got hit that interface, and thereafter it bounced like this. It bounced back into the same medium. This phenomenon we have to call as a reflection of light. See what means reflection of light? The bouncing back of the light into the same medium when it strikes any reflecting surface. Means what? When that light is going to hit or it is going to strike any reflecting surface. Reflecting surface means what? Their top surface being reflecting and their bottom surface being coated. Because of that coating, that medium is not allowing that light ray to pass through it. Because of that painting, that medium bouncing back that light into the same medium from where it came. This phenomenon we have to call as a reflection of light. The bouncing back of the light ray into the same medium when it hits any reflecting surface is called as a reflection of light. Here that light ray which is coming and striking the surface is called as incident light ray, and the light ray which bounced back is called as reflected light ray. And this point here, you just look on this one. This point at which that light got incident is called as point of incidence. The point at which that incoming light got incident is called as point of incidence. Here what we have to do firstly while drawing the diagrams, it's very important. See where that light ray is going to strike, at which point that incoming light is going to strike that surface. To that point, firstly you have to draw one perpendicular line. To that point of incidence, firstly you have to draw one perpendicular line. That perpendicular line drawn at the point of incidence is called as normal. It's very important. While drawing the diagram, you must and should draw a perpendicular line at that point of incidence to that interface. Yes. Thereafter drawing that normal. Here I have mentioned I and R. Here I is the angle of incidence and R is the angle of reflection. These two angles we must and should measure with respect to the normal. You see here, this light ray is coming and going to hit that surface at this point and going to bounce back. Here it is coming in this plane. This is plane. Obviously it going to subtend certain angle. Here that angle we have to take with respect to normal. It's very important. See along which direction that light is coming. To say that we need reference here. That reference you have to take with respect to normal. I mean you must and should measure that angle of incidence with respect to normal only. So this is the angle of incidence. And here thereafter getting incident on that, it bouncing back and moving in this plane. Obviously it has one direction. To specify that, again we need one angle. Again here that angle we have to take with respect to normal only. Here this is called as angle of reflection. This is called as angle of reflection. This phenomenon we call as reflection of light. See here, after that when light is coming like this and going to hit on any reflecting surface, thereafter it is bouncing back into the same medium. Here according to the geometry, here there are two laws. Here there are two laws of that reflection phenomena. We should know those two laws of reflection. First one, this angle of incidence is equal to the angle of reflection. In all reflection phenomena, that angle of incidence is going to be equal to the angle of reflection. This is first law of reflection. According to that geometry, everywhere wherever that reflection phenomena is going to takes place, there we have to say that angle of incidence is going to be equal to the angle of reflection. This is first law. Thereafter, second law is there. What that second law is telling? Second law telling this incident light ray and this reflected light ray and normal drawn to the point of incidence all are lying in the same plane. What it telling? Incident light ray, reflected light ray and normal drawn at the point of incidence, all are lying in the same plane. Means what? Just look here. You treat this as an interface. This is interface. So now this is incident light. This is interface. See here, this is incident light ray. How I am taking? You just here I said about planes. See here. Plane, 3 coordinates there, x, y and z. Coordinates means reference lines. We need reference to say the position of anything, where it is. To say that we need reference lines. Those we call as coordinates. There are 3, x, y and z. Suppose this is x line and this vertically held one y line, and which is coming towards you is z line. With the help of these 3 lines, we are going to say the position of anything, where it is. So now you see here, you be with these coordinates x and this is y. This plane, this vertically held plane we call as xy plane, x-axis, and this is y-axis. Then this vertically held sheet is called as xy plane, and this one is z-axis. This horizontal plane is called as xz plane, xz plane. And one more thing is there. This line is z and this one is y. Then this one vertically held like this called as yz plane. These are planes. xy plane, xz plane, and this is yz plane, vertically held plane. Now what I mean to say, you see here, this is our interface. Now I am going to take this light ray which is coming like this. It is coming in which plane? xy plane. This is xy plane, vertical held sheet. You treat this incoming light is along which plane? xy plane. It is coming like this. Suppose if I take it like this, it is not on xy, not on xz, yz. It is in xyz plane. I am not saying like that. I am taking this one along vertically held plane, x and y plane. Yes, you see. This light ray is coming along this xy plane and striking this interface at this point. This is, you treat it like this. This is incident light. What I said, to that point of incidence you must and should draw one normal. See, this is normal. This is normal. This is incident light. And this is normal. This is angle of incidence. Now it is coming and it's going to hit this. Yes, it got hit here. Now it is going to bounce. How it going to bounce? You see here. That reflected light ray, see here what I mean to say. This is the reflected light ray. This is reflected. Incident. This is reflected and this one is normal. All these 3 lines, see here, incident light ray, reflected light ray and a normal drawn at the point of incidence. These all 3 lines are lying in the same plane. These all 3 right now are lying in x, y plane. This is x-axis. This one y-axis. These 3 lines right now lying in this vertically held plane. These 3 are in the same plane. That is only second law. That second law of reflection telling incident light ray, normal drawn at the point of incidence and reflected light ray all are lying in the same plane. This is second law. First law, this angle of incidence is equal to angle of reflection. These are very important laws of reflection. Concentrate here on this one. With the help of this reflection phenomena, later we are going to understand TIR, total internal reflection. See, actually in this 2020-21 academic year syllabus, they have removed this reflection. It deleted from the portion. Even though we should know what mean reflection and what are their laws of reflection. With the help of these, later we are going to understand some few things. That's why I said briefly about reflection and laws of reflection. Reflection is just the bouncing back of the light into the same medium when it strikes reflecting surface. That has two laws. One is angle of incidence is equal to the angle of reflection, and another one is incident light ray, reflected light ray, and a normal drawn at the point of incidence. All are lying in the same plane. It's very important. Yes. After this reflection, now we are going to discuss about what do you mean by refraction of light. It is another property of light. How reflection is one property, like that refraction of light is another property. So what mean refraction? See here, just have a look on this diagram. Here I have drawn one diagram. Here this is one glass slab. I have mentioned somewhere here. I mean, it is, you just look on this diagram. This is one glass slab. I mean, a glass medium with certain thickness, this much. It looks like a rectangular glass slab. It held like this, horizontally. Their top surface, which is their top surface, E, F, G and H, is the top surface of that horizontally held rectangular glass slab. I mean, it's a glass material, glass sheet. See here, look here. What happening here? It has certain thickness. So what happening here? Above that glass slab, I mean this glass slab is surrounded by a homogeneous medium. This glass slab surrounded by homogeneous medium means what? Around this glass slab there is air medium. In all direction air is there. Homogeneous means that medium being with the same concentration of the molecules. Everywhere around that glass slab homogeneous medium is there. Above glass slab air is there. Just you see, imagine like this, a light ray, concentrate on this AO. AO is the light coming from back side to here. I mean it propagating along AO direction. It is coming and going to strike that surface obliquely. See, obliquely means what? What I mean to say, that I said it is horizontally held sheet. This is horizontally held glass sheet. Here, this is y-axis and this one is x-axis. So now, oblique incidence, it's very important. You should know what means oblique. Oblique means neither parallel nor perpendicular to the specified surface. Means what? This is our glass sheet, horizontally held. Top portion, this is their top portion. To this top portion, to this E, F, G, H surface, it is horizontally held right now. To this horizontal surface, if a light is falling obliquely means what? That light that direction neither parallel nor perpendicular, then it is called as oblique. If it is coming like this means how it looks? It looking parallel to the surface, then we should not call it as oblique. If it is coming like this means what? To that surface this light ray is being perpendicular, then also we should not call it as oblique. Oblique means neither parallel nor perpendicular to the specified or any concerned surface or line. Getting? Means what? It should not come like this or it should not come like this. It should lie between these two lines. I mean, this is called as oblique. This direction is oblique now. Why? It is not parallel, not perpendicular. Then it is called as oblique. Have you understood? Oblique, very important. While while telling the definition of refraction, you must and should use this oblique word. Very important. Oblique means neither parallel nor perpendicular to the any specified surface. Now you see here, this AO line, it is a light ray. How it is inciding on that horizontally held EFGS surface? This AO light ray is inciding on that EFGH surface obliquely. This is EFGS. This light ray is coming like this. It got incident on that obliquely. Yes. Thereafter, what happening? Look on that. That AO got incident on that glass sheet at point O. Thereafter, here while discussing about the refraction, we should take or we should allow that light ray to pass through the transparent materials. Transparent materials means what? The materials which allowing the light rays to pass through it, to pass through them, called as transparent material. When we are discussing about reflection, there will be with the material, their one side surface being coated. Why? Because there that coated surface not allowing light rays to pass through it. That's why light rays got bounced back. That we call as reflection. When talking about reflection, that medium through which light moving, their one surface should be coated. But when we are talking about refraction, there should not be any coating. Refraction, that word only telling light rays are passing through such materials called as transparent material. When we are talking about the refraction, we have to take transparent medium, means the medium through which light ray is passing. Like that, here this our glass slab is transparent. That's why when that AO light got incident on that transparent glass slab at point O, thereafter that light AO is passing through that glass slab. When that light AO enters into that glass slab, that light ray is bending towards the normal drawn at that point of incidence. You see here, AO, incident light ray. O is a point of incidence. O is a point of incidence. What I said while drawing the diagrams, we must and should, firstly, how to draw the perpendicular line to that point of incidence, which we call as normal. Here O is the point of incidence. To that O, we have to draw one perpendicular line. Imagine inside the slab also. Say this one, this is above the glass slab, perpendicular line. This we call as normal glass slab. This is above. It has certain this much thickness. This is O point. Imagine this is thickness of that sheet. This is O point. This is normal. It is above also there and inside also there. Try to get what I mean to say. Inside also there. This is top surface. This is your O point. This is your normal like this. Imagine like this. This is your normal. That light ray got incident like this. And when passing through that glass slab, it bending towards this normal, bending instead of going straight. You look here. AO is incident, got incident at O. Instead of going straight, instead of going along this dotted line, that light ray when enters into the glass slab, you look on this OB line. OB, it bent towards the normal. This line is normal. This is normal. Look on OB line. OB line. That OB is through the glass slab. This is slab. Through this one. This is normal. It bent. OB. Instead of going straight, it bent towards the normal. Instead of going along this dotted line, it moved along OB. That OB line, that refracted light bent towards the normal. This OB we call as refracted, transmitted. That transmitted or refracted light ray bent towards the normal. This phenomenon we call as refraction of light. Refraction of light. You see here. Now I am going to define that. What refraction of light? The bending. See, you just look on this. Instead of going straight, it being like this. AOB. Look on AOB. By having a look on AOB, we can say that light ray bent. It came like this and bent like this. This phenomena we call it refraction. How we to define this now? You see here, the bending of light ray when it is moving from one medium to another medium, when it got incident on it obliquely. The bending of light ray when it moving from one medium to another medium, when it got incident obliquely. This bending phenomena is going to take place only when that light is going to incident obliquely. That we must and should tell. If it is hitting that surface perpendicularly, you see this is glass slab. Imagine this is only light ray, a light ray. How it is striking now? It is not oblique now. It normally incidencing. It normally hitting, perpendicularly hitting. Then this light ray keeps moving without any deviation. That light ray moving straight only, that not bending. When it is going to bend, when it has to get, when it is going to incident obliquely. That's why while defining the definition, we must and should say that oblique word. The phenomenon of bending of a light ray when it incident obliquely on any transparent